Good morning students, this is Latif sir. In this video, today I will discuss about p block elements. In periodic table, group 13 to group 18, group 13 to group 18 elements are known as p block elements. Group 13 to group 18 elements. Among these six groups, we have already studied about group 13 and group 14 in class 11, and in class 12 we have to read about group 15, 16, 17 and 18. These four groups are given in class 12. Okay, group 15, 16, 17 and 18. In group 13 and 14 group 13 and 14 is you have already studied in class 11. Okay, so see, general electronic configuration of all these groups are given here. Okay, p block elements generally have electronic configuration nh2 np1 to 6. This is the general electronic configuration, and oxidation number of stable oxidation number of elements of each group is given here, you can see, and first member of each group is given in this table, you can see. An electronic configuration of common electronic configuration of all the member of a particular group is also given. Okay, for example, in group 15 the general electronic configuration is nh2 np3. Okay, in group 16 general electronic configuration is nh2 np4. In group 17 general electronic configuration is nh2 np5, and in group 18 general electronic configuration is nh2 np6. Okay, and their oxidation number also given, common oxidation number. So p block element, this is chapter 7. Some points regarding p block elements are given here. I have already told that elements belonging group 13 to group 18 in the periodic table are known as p block elements. And their general electronic configuration of p block elements is nh2 np1 to 6. Okay. And inert pair effect. What is inert pair effect? The tendency of nh2 electron pair to participate bond formation decreases with increase in atomic size. In p block elements, the tendency of nh2 outermost nh2 electron pair to participate in bond formation decreases with increase in atomic size. Within a group, the higher oxidation state become less stable with respect to the lower oxidation state as the atomic number increases. As we move down in a particular group in p block elements, the outermost nh2 electron pair become inert, and outermost nh2 electron pair become inert. Okay, and become the outermost nh2 electron do not participate in bond formation down the group in p block elements. Okay, and this is known as inert pair effect, and this trend is called inert pair effect. In other word, you can say the energy required to unpair the electron from nh2 orbital is more than energy released in the formation of two additional bonds. Okay, so down the group inert pair effect increases, and due to inert pair effect the outermost nh2 electron of p block element, due to inert pair effect the outermost nh2 electron in p block element become inert and do not take part in bond formation, and therefore the lower valency become more stable than higher valency down the group. Okay, and in p block element in class 11 you have already studied about group 13 and group 14, and in class 12 you have to read about group 15, 16, 17 and 18. So nitrogen family is the group 15. Group 15 is also known as nitrogen family, and the member of nitrogen family are nitrogen, phosphorus, arsenic, antimony, bismuth, and their electronic configuration is nh2 np3. Oxygen family group 16 is oxygen family, and the element of group 16 are oxygen, sulfur, selenium, tellurium and polonium, and their general electronic configuration is nh2 np4. Halogen family, their electronic halogen family group 17, that is fluorine, chlorine, bromine, iodine and astatine, and they are also known as halogen. Okay, and their general electronic configuration is nh2 np5. and group 18, that is noble gas or inert gases. In group 18 elements also known as noble gas or inert gas, helium, neon, argon, krypton, xenon and radon, these are group 18 elements. Okay, and their electronic configuration is NH2 NP6. Except helium, all the other noble gases have electronic configuration NH2 NP6. Only helium has electronic configuration 1s2. And due to stable electronic configuration, noble gases are or group 18 elements are chemically less reactive. These are brief discussion about p block elements. Now separately you have to read about group 15, group 16. Okay, so first group 15, group 15 elements, that is nitrogen family, nitrogen, phosphorus, this family. Okay, atomic size and atomic radius, you have to electronic configuration is given. General electronic configuration is NH2 NP NP3, group 15 elements. And their atomic and ionic radii, covalent and ionic radii increases down the group. This is simple variation. Down the group their size increase. Ionization energy of group 15 element, it goes on decreasing down the group due to increase in atomic size. Group 15 elements have higher ionization energy than group 14 elements due to smaller size of group 15 elements. Group 15 elements have higher ionization energy than group 16 element because they have stable electronic configuration, that is half fill electronic configuration. Now oxidation state, common oxidation state of group 15 element is +3, +5 and -3. Common oxidation state of group 15 element is are +3, +5 and -3. And the tendency to show -3 oxidation state decreases down the group due to decrease in electronegativity, which is due to increase in atomic size. And the stability of +5 oxidation state of group 15 element decreases, whereas +3 stability of +3 oxidation state increases due to inert pair effect. In group 15, +5 oxidation state, stability of +5 oxidation state decreases, whereas stability of +3 oxidation state increases down the group due to inert pair effect. And nitrogen show oxygen state from -3 to +5. Okay, now reactivity of group 15 element towards hydrogen. All group 15 elements form trihydride like NH3 PH3 NH3 PH3 NH3 PH3 ASH3 SbH3 BiH3. All group 15 element forms trihydride, and the hybridization of central atom of trihydride is sp3. Okay, so stability of trihydride of group 15 element decreases down the group due to decrease in bond dissociation energy down the group. For example, stability of NH3 is less than stability of stability of NH3 is greater than stability of PH3 is greater than stability of ASH3 is greater than stability of SbH3 is, which is greater than stability of BiH3. Okay, so you have to read about this order, stability order of hydride of group 15 element: NH3 greater than PH3 greater than ASH3 greater than SbH3 greater than BiH3. Now boiling point order of group hydride of group 15 element. Boiling point decreases from PH3 to ASH3. So boiling point of pH3 is less than boiling point of AS arsenic hydride, which is less than ammonia. Boiling point of ammonia. Ammonia has abnormally higher boiling point than pH3 and AS3 due to hydrogen bonding. Okay, so boiling point increases with increase in size due to increase in van der Waals forces, and boiling point of ammonia is more because of hydrogen bonding. So boiling point order is pH3 less than boiling point of ASH3 less than boiling point of NH3 less than boiling point of SbH3 less than boiling point of BiH3. Okay, so you have to remember the boiling point order. Okay, now bond angle order of hydride trihydride of group 15 elements, that is bond angle of NH3 is greater than bond angle of pH3 greater than bond angle of ASH3 arsenic hydride, which is equal to bond angle of SbH3 which is greater than bond angle of BiH3. Values are given. Okay, just remember the order. And the reason of this type of bond angle is given here. Electronegativity of nitrogen is highest, therefore lone pair will be towards nitrogen atom, hence more repulsion between bond pairs of nitrogen in NH3. That is why the bond angle is in NH3 is highest. After nitrogen, electronegativity of the element decreases down the group, and therefore bond angle decreases, repulsion decreases, bond angle also decreases. And basicity of trihydride of group 15 element, basicity order, basicity of NH3 is the highest basic. NH3 basicity of NH3 is greater than basicity of pH3 is greater than basicity of ASH3 greater than basicity of SbH3, which is greater than basicity of BiH3. So basicity decreases from ammonia basicity of NH3 is greater than basicity of pH3 is greater than basicity of ASH3 greater than SbH3, which is less than BiH3. Okay, so this is because the lone pair of electrons are concentrated more on nitrogen atom, and hence basicity will be maximum in case of ammonia, and it will decrease down the group as electronegativity decreases down the group. And the reducing power of hydride of group 15 element, that is reducing power of NH3 PH3 SH3, reducing power of group 15 hydride of group 15 element increases down the group due to decrease in bond dissociation energy down the group. And now see reactivity towards oxygen, reactivity of group 15 elements, and they form trioxide, that is trioxide like M2O3, and pentoxide like P2O5, M2O5. This M is general representation, M2O3 like N2O3, P2O3, or M2O5, that is P2O5. Group 15 elements form trioxide and pentoxide, and these are acidic oxide. So acidic character of this trioxide and pentoxide of group 15 element decreases, and basicity increases down the group. This is because the size of nitrogen atom is very small, and it has a strong positive field in very small area. Therefore it attracts the electron of water's OH bond to itself and release H plus ion easily. So it is acidic in nature. But acidic property of oxide of group 15 element decreases down the group. As we move down the group, atomic size increases, and hence acidic character of the oxide of group 15 element decreases, and basic character increases. And reactivity towards halogen, group reactivity towards halogen, group 15 elements form trihalide and pentahalide. Group 15 elements form trihalide like NCl3, NF3, and pentahalide like PCl3, PCl5. Okay, and in trihalide, the hybridization of the central element is sp3, and the structure is pyramidal shape. The shape is pyramidal. In pentahalide like PCl5, the hybridization is sp3d hybridization, and the shape of this pentahalide is TBP, trigonal bipyramidal shape. And PCl5 is ionic in solid and exists as PCl4 plus and PCl6 minus. structure of PCl5 is given here. In PCl5, pentachloride of phosphorus, there are 3 equatorial bond and 2 axial bond, and the axial bond are longer than equatorial bond because of greater repulsion from equatorial bond. And nitrogen do not form pentahalide due to absence of d orbital in nitrogen. And reactivity towards metal not given. Anomalous behavior of nitrogen. What is the cause of anomalous behavior of nitrogen? Because it has small size, it does not have d orbital, it has high electronegativity, it has high ionization energy. Now see some compounds of group 15 elements. First compound is dinitrogen, N2. Preparation of dinitrogen is given in the syllabus from ammonium dichromate. You have to read the second reaction. Ammonium dichromate, NH4 whole twice Cr2O7. On heating, it gives N2 plus 4H2 plus Cr2O3. This reaction is given. Okay. Now properties of dinitrogen: it is colorless, odorless, tasteless, and non-toxic gas, and it is chemically unreactive due to presence of triple bond between two nitrogen atom in dinitrogen. Okay, that's why bond dissociation energy is very high in dinitrogen. And second compound of nitrogen of this group, ammonia NH3. It is a trigonal pyramidal shape. The shape of ammonia molecule is trigonal pyramidal, and nitrogen has one lone pair and 3 bond pair, and the nitrogen atom is sp3 hybridized. And preparation of ammonia, method of preparation of ammonia using Haber process. In Haber process, nitrogen gas react with hydrogen gas N2 plus 3H2 to give ammonia 2NH3. In this reaction, FeO, iron oxide, act as catalyst, and small amount of K2O and Al2O3 is also used. And chemical reaction of ammonia is given in syllabus. Reaction of ammonia with copper, you have to read from your book, it is not given in this PDF. Reaction of ammonia with copper. Okay. And nitric acid also given in the syllabus. Nitric acid, preparation of nitric acid. When ammonia gas react with oxygen gas 4NH3 plus 5O2 in presence of platinum and rhodium catalyst, platinum PT and RH catalyst, at 500 Kelvin temperature and almost 9 bar pressure, ammonia gas combine with oxygen gas 4NH3 plus 5O2 to give 4NO plus 6H2. Okay, this is the preparation of ammonia nitric acid gas. Okay, in this reaction, first NO combine with oxygen to form NO2, and NO2 one more preparation is given. One is Oswald process, one more preparation is given, NO plus O2 to give NO2, and NO2 reacts with water to give HNO3 and NO. Okay. And NO thus formed is recycled, and the aqueous HNO3 can be concentrated by distillation up to 68% by mass, and further concentration to 98% can be achieved by dehydration with concentrated sulfuric acid. And nitric acid is a strong oxidizing agent. And phosphorus and phosphine not given in the syllabus, not required. Phosphorus and phosphine. Now group 16 element similar to group 15 element. Similar properties. First oxidation state of common oxidation state of group 16 elements are -2 +2 +4 and +6. Oxygen does not show +6 oxidation state due to absence of d orbitals, and polonium does not show +6 oxidation state due to inert pair effect. Okay, and the stability of -2 oxidation state decreases down the group due to increase in atomic size and decrease in electronegativity. And for oxygen, -2 oxidation state is more stable. Okay, and oxygen shows -2 oxidation state in general except in OF2 and in O2F2. And the stability of +6 oxidation state decreases and stability of +4 oxidation state increases down the group due to inert pair effect in group 16 element. And ionization energy. Ionization enthalpy of group 16 element is lower than group 15 element due to half filled p orbital in group 15 element which are more stable. Okay, and ionization energy decreases down the group. Electron gain enthalpy. Group oxygen in group 16, oxygen has less negative electron gain enthalpy than sulfur. In group 16 element, oxygen has less electron gain enthalpy than sulfur because of small size of oxygen. From sulfur to polonium, electron gain enthalpy become less negative to polonium because of increase in atomic size. Okay, melting point, boiling point not required. Reactivity with hydrogen. All group 16 elements form hydride. All group 16 elements form hydride like H2O, H2S, H2AC, H2TE. Okay, all group 16 element form hydride like H2O, H2S, H2AC, H2TE, and their bond angle you have to read. Bond angle of H2 is greater than bond angle of H2S, which is less than H2AC, which is less than H2TE. An acidic character of groups hydride of group 16 element, that is H2O less than H2S less than H2T less than H2AC less than H2T. Okay, so acidic nature you have to remember. Order of acidic nature of group 16 element, hydride of group 16 element. Acidic nature order is H2O less than H2S less than H2AC less than H2T. And thermal stability order, H2O, thermal stability of H2O is less than thermal stability of H2S is less than thermal stability of H2AC is less than thermal stability of H2T is less than thermal stability of H2PO. This is because the hydrogen and group 16 element bond length increases down the group, and therefore bond dissociation enthalpy decreases down the group. And reducing character in of group 16 element, H2 has less reducing character than H2O has less reducing character than H2S, and reducing character increases down the group. Okay, so the reducing character order is H2O less than H2S less than H2AC less than H2T less than H2PO. Reason is given. Reactivity with oxygen, and group 16 element form oxide like EO2 EO3 like SO2 SO3. Okay, and SO2 is a gas whereas ACO2 is a solid. This is because ACO2 has a chain polymeric structure whereas SO2 forms discrete unit. Okay, why SO2 is a gas and SO2 is a solid? Because SO2 has a chain polymeric structure whereas ACO2 has chain polymeric structure whereas SO2 form discrete unit. And now reactivity with halogen. All group 16 element forms halide like EX2, EX4, EX6 like SF4, SF2, SF6. Okay, and the stability of halide decreases in the order if fluorine greater than chlorine greater than bromine greater than iodine. This is because EX bond element and halogen bond length increases with increase in size. Among the hexafluoride, fluoride are among hexafluorides SF6 more stable okay. Among the hexahalide fluorides, hexafluoride are more stable because of steric reason. That's why SF6 is more stable. Okay. Now compound one question is given. H2O water is a liquid and H2S is a gas. Why? This is because strong hydrogen bonding is present in water, and this is due to small size and high electronegativity of oxygen. In water, strong hydrogen bonding is present, that's why water is liquid and H2S is a gas. And now preparation of oxygen, oxide, these are not given in the syllabus. Ozone is given, sulfur is not given. Ozone, preparation of ozone from oxygen, O2 to O3, 3 O2 combined to give 2O3, ozone to O2 to oxygen. Okay, so ozone preparation, it is prepared by passing silent electric discharge through pure and dry oxygen. 10 to 15% oxygen is converted into ozone. So the reaction is 3O2 gas arrow 2O3. Sulfur is not given in the syllabus, but you have to read the reaction of chemical property of ozone. Chemical property of ozone. Ozone is thermally unstable. Decomposition reaction of ozone. It is unstable and easily decomposed to oxygen at 300 degrees Celsius. O3 to, the reaction is O3 to arrow 3O2. And oxidizing nature, reaction of ozone with FeSO4 in H2SO4. Ozone acidified ferrous sulfate converted into ferric sulfate. This is oxidizing property of ozone. Ozone oxidizes a ferrous sulfate to ferric sulfate and itself reduced to oxygen. So the reaction is 2FeSO4 plus H2SO4 plus O3 arrow Fe2SO4 whole thrice plus water plus O2. And ozone react with Ki solution, Ki plus O3 plus water to give 2 KOH plus I2 plus O2. And reaction of ozone with PBS given in the syllabus. Lead sulfide, which is black, is oxidized to lead sulfate colorless. The reaction is PBS plus 4O3 to PbSO4 plus 4O2. And reaction, moist iodine is oxidized to iodic acid. Reaction is given here, you can see. Reaction between Ki and O3. Ki react with ozone to give KiO3 and 3O2. Similarly, Ki react with 4O2, 4O3 to give KiO4 plus 4O2. And one important point about ozone is given here. It is tailing of mercury. Mercury in presence of ozone is oxidized to sulfur dioxide, which dissolve in mercury, and it sticking to the glass and loses mobility, and hence mercury loses its meniscus in contact with ozone, and this is known as tailing of mercury. And the reaction behind this is Hg plus O3 to give Hg2O plus O2. And now sulfur dioxide preparation, method of preparation of sulfur dioxide gas from sodium sulfide. Sodium sulfide, when combined with H2SO4, it will give sodium sulfate, water and sulfur dioxide, SO2. It is given in the syllabus, preparation of sulfur dioxide. Okay. And industrial preparation of sulfur dioxide from Fe2S3. When Fe2S3 combined with oxygen, it gives FeO plus 3SO2. And liquefaction of sulfur dioxide. Chemical properties of sulfur dioxide, it is acidic in nature, acidic oxide, it is readily dissolved in water. Sulfur dioxide break up in water and gives out sulfurous acid, and it reacts with sodium hydroxide solution to form sodium sulfide. Okay, so reaction between SO2 and NOH, important reaction to give Na2SO4, NO2SO3 and water. And reaction between sulfur dioxide and chlorine is also important. Sulfur dioxide reacts with chlorine to give sulfonyl chloride, sulfuryl chloride, SO2Cl2. SO2 plus Cl2 implies SO2Cl2. Okay, and sulfur dioxide decolorize acidified KMnO4 solution. Sulfur dioxide react with potassium permanganate to give potassium sulfate, manganese sulfate and sulfuric acid, and the reaction is SO2 5SO2 plus 2 KMnO4 plus 2 H2O implies K2SO4 plus 2 MnSO4 plus H2SO4. Okay, and last sulfuric acid not given in the syllabus. Okay students, and next day I'll discuss about group 16 and 17 and 18. Today I have discussed about group 15 and 16, and next day I'll discuss about group 17 and 18. Thank you, students.